Good afternoon, students.
Good afternoon, sir.
Yeah. So you joined via online, right? Online.carnea.edu, right? Anybody joined without online.carnea.edu? How you people joined our class?
Online
Sir,
portal,
through
sir.
online dot.
Okay.
Online portal, sir.
So please join only via online.carnea.edu, right? I think you must be having that from the next previous semester itself. If not, you can join that. Some students told they are without such options. You join that and makes necessary steps and join only via online.carnea.edu. I was not sure whether it will work or not. So I copied and pasted the link in the GCR also. From next class onwards, I will not paste in the Google Classroom, right? You must join only via this option. So I need not click and admit you every time whenever you enter. So we will go into today's lecture session. Is my screen visible?
Yes, sir.
So last class we stopped with some examples. And this is what you have to keep in your mind, right? Schema of machine learning, or what is machine learning all about. Whenever students approach me for some projects or anything like that, immediately they talk about some very supernatural things, right? Like something different, extremely different. But machine learning is a part. That is the system of artificial intelligence. But for doing artificial intelligence, you must be thorough with many different aspects of artificial intelligence. But what we are studying in our subject is only a part of your artificial intelligence, which is completely software based, right? A program or a model. That is what we are going to design or develop. So this is the actual schema of machine learning. So as I told you in the last class, the computer is the middle block, right? Where we are going to get the data, and in machine learning, we are going to have the output also given us. Maybe I will show the slide also. Look at the second one. The output also given as input, and we are going to have a program as an output. It's not an exactly output. It is wrongly written here. It is a program which we are going to call it as a model, right? So this is the way how a machine learning is going to work. So when you zoom down into that specific block, you can get this. Inside the computer, right? Inside the middle block of the computer, you have two subblocks. One is called as the learner. One is called as the reasoner. Right? What the learner is going to do, it is going to get the input data or the experience data or the past history, or we call it as training data. If you want to recognize face images, right? First, you need to train the machine with all the face images of those people whom you want to recognize. That is given. Along with that, an additional information is a background knowledge. What is that background knowledge? A face will have eyes, will have lips, will have nose, will have eyebrows, and based on those features, right? Based on those features, you can come to a conclusion, because one person's eye may be different from another person's eye, right? So the sub features, when you say data, it is the complete image, but what is present within that image, right? If it is if you are identifying a cat within a cat in a garden image, right? Then the cat will have tail, that stripes, right? The claws, the paws, Everything has to be specified in the background knowledge. So with the help of these two things, the learner will learn. It is not going to take a decision. Remember, the learner will not take a decision. It is only learning how you are doing in this 3-month online class. It is going to learn, and finally create a model. Model is a program, right? For that program, it is sufficient for you to change only the input data. When you change the input data, it will tell you whether this is the face of so and so, so and so, so and so. Right? This is the concept of machine learning. Not only in face recognition, in all pattern recognition, as I told you in the previous class, for all pattern recognition applications, you can do machine learning. A pothole detection in a highway is normally all the vehicles will go at a faster speed, right? But nowadays what happens is, because of several reasons, we have many potholes in the road. In nighttime, it is going to be dangerous. So can we detect the potholes from the image? Machine learning can do, right? A fake currency note, it can do. A spam email, whether it is a correct mail or a spam email, you must be using Gmail and so many things. Some mails are automatically sent to the spam folder. How? We have a machine learning model there. So based on this learner, it creates a model. Now, once you have a model, now the problem or the task is given. What is the problem or task? Any new image, if it is the case of a face recognition, right? We have learned everything. I will teach you, say for example, if I am teaching you addition, I will teach you 2 plus 3 is equal to 5, 5 plus 6 is equal to 11, 7 plus 8 is equal to 15, so and so numbers, right? But when what I will ask in the exam, what is 100 plus 122, right? If I'm asking the same question, what I'm teaching in the class, then there is no meaning of learning. Don't get scared that I will ask tough questions in the internals. It is not like that. I'm telling you the general process of learning, right? Then there is no meaning in learning. If I tell 3 plus 5, and if I ask you 3 plus 5, definitely another twisted question you may not be able to answer. So that process of examination is done by the reasoner. In the problem or task, the problem remains the same. Face recognition, this model is used for only face recognition. But the problem or the task means a new image, new face image is given. When a new face image is given, you are going to get the answer. Okay, this is the face of so and so. So whatever we saw in the previous class in the compressed form, here it is given in an expanded form. This is what machine learning is all about. Don't think too much beyond, right? But when you learn NLP, computer vision, and all those things, right, will add on to together, and then it may help you in going for the model. As I told you, if you want to go for hardware, you need the support of people working in the hardware area. But if you are a data scientist, right, you are not bothered about hardware. So your duty or your job, even in the companies, is to develop algorithms, develop innovative models, what changes you can make in the existing models to make sure you can recognize in the best possible way. After that, your algorithms, your methods will be taken, and some other people will be there who will put in the hardware in the form of something. Right? You must have heard about prosthetic arms, right? A person who was injured in an accident can be replaced with the arm, right? An engineer like you cannot do the complete arm. What is your, if you are a data scientist, you must have the fingers picking the specific object. What finger should be used for picking the specific object, right? How do you hold a mobile? It is not same as holding a glass, right? Or holding a hot cup of coffee. We use different fingers, right? So you can develop models in the form of a program, right, which can be used to grasp different objects in the real-time scenario. Exactly like if he has some real hand, how he will do, he can do with the artificial hand also, right? This is one part. Likewise, when many parts club together, the industry peoples, those who are having some hardware options, manufacturing facilities, they finally create something. But you may be the owner, the patent holder, or the copyright of that idea or specific things. This is the way how machine learning course. Right? I hope this is the important slide. If you can understand this slide, definitely all the concepts which you are learning and in the project, even you whatever you are going to do, you will know. Right, this is a simple example for the previous one, right? A practical example, right? A person, you can ask your machine nowadays with Alexa, with Google, and all those things. You can just speak to the phone, and the phone will give you the answer, right? What happens? Let us see. A person is asking, "Hey Siri, Siri is a machine learning device. How far is the nearest subway?" Right? Then it is going to capture the information. You have a sensor. Right, the sensor is going to capture the information, and your information in the form of signals. Right, now the data comes into picture. Your previous experience is data in the form of signal. So signal, image, text, these are the three things which is very important for you: video, animation, graphics. So first of all, when you go for working with machine learning or ML, check what is the nature of the data. Then we have some process. Depending upon the algorithm which we are going to study, it will decode, it will process, it may do a match, and finally it will give a desired output. Desired output is also in the form of a signal, right? So signal to signal is your job. Now what happens? This signal can be taken and inbuilt with them in the form of a chip, or maybe an interface, a hardware interface, where the mobile phone or the Siri can tell you that it is 4 kilometers away, right? So the important thing is what is happening inside. It is not outside. People think about the outside part and they talk about many things, but it is the ML developer, the data scientist, who has to break his head and develop something inside that. I hope many of you must be wearing smartwatch, right? People look at the smartwatch and they buy, this model is good, this color is good, and this is good. But what happens deep within that is important. Right, your heart rate is detected based on your blood flow. Right, when you wear your watch has a sensor which senses the blood flow, and there are ML programs, ML algorithms, which is going to give different results for different flow. Right, that is the job of a ML engineer, or to be frank, a data scientist. Right? So your objective or your way in which you are going to do, suppose if I ask you to write a program or a mini project or an assignment, something like that, your focus also should be right. And we have some opinions or views of many people across the world. So the first one is machine learning is going to search a very large space of possible results. Right? When I give my face image, it is going to compare my face image with all the images which I have trained with. When I say data, not only my data, our department, complete faculty data may be there. So when I go and stand in front of the thumb punch-in machine, right, it is going to recognize. So what it is going to do? It is going to compare with all the data. So it is going to search a very large space and find which is the best one. Again, the problem is when the data increases, again, the machine may get stuck and there may be problem. That is another area of research which we call it as big data area, where we will not go much into that. And there are some issues in ML, and there are some concerns, right? What algorithms? We are going to see many machine learning algorithms exist for learning general functions from specific training examples, right? That means specific example, specific training example. I'm giving my face image. Later on, when I grow some beard, when I wear spectacles, right? When I change my hairstyle, right? Still, if can the algorithm recognize me? Can it generalize my name from specific training examples instead of training every time with all different varieties of my image? Just by giving one image, whatever image, when I go for giving it in the reasoner block, right, in the testing block, or in the problem or the task block, can the reasoner identify that it is Jude, right? It is still under work. Right? So if you do some project like that, it will be of much interest to the research community. In what settings will particular algorithms converges to the desired function given sufficient training data? In algorithm, we have many parameters. You know, algorithm is a step-by-step procedure where we have many variables. what should be the values of the variables. Till now, there is no concrete evidence that you should use a is equal to 5 or b is equal to. It's only a trial and error method. Which algorithms perform best for which type of problem and representation? This all the project students will come and ask. Sir, I want to do some, say for example, uh, face recognition. If I want to do face recognition, what algorithm should I use? Till now, there is no fixed answer. It is like if you want to eat biryani, you go to this shop. There is no recommendation like that. Sometimes that biryani may be good. Sometimes that biryani may not be good. Right? Again, it depends upon the images. These are some of the issues which I'm posing to you. So when you go to your final year or your MTech or something, if you're interested, you can take some problems here. How much training data is sufficient? Sir, is one image. Some people, some of our project students come and show the results. How many images you have taken? Only 2. That is not sufficient. Then immediately he will ask, okay, sir, tell me how many. Even I do not know. Right? More the better. That's what I can tell you. When and how can prior knowledge held by the learner guide the process of generalizing from examples? Right? Background knowledge, the features, not the complete data, but the internal features which are given to the learner. Remember, we have a learner, reasoner. Learner is only learning and creating the model. Reasoner will take a new image and create a output. So the knowledge which is obtained by the learner, how far it is going to help the reasoner. They both the computer is having both the blocks. They don't have much difference between them. But how it is going to do the testing process? That is another interesting question. What is the best strategy for choosing a next training experience? Interesting question, right? Say for example, weather prediction. Right, yesterday from evening from 7 to 1, it was raining very heavily in Karunya Nagar. Right, if you would have asked me on a Sunday or Monday or in the previous class, sir, do you think it will rain on the say for example Wednesday, right? I would have said no, because it was completely, there's no symptoms of raining. But what happens is suddenly it rains. But it would have shown some symptoms just before it rains. That means there are some applications which need continuous data gathering. The past history of data may not be useful for that machine learning algorithm to give a conclusion. Right? So when should I gather the next training experience? Right? The wind generation in the turbo wind wheels. Right? When is the good time we'll get more air? Right? For that prediction also we go for ML. But till now there is no best study. Okay, you take the 30 minutes survey of the data. It is just a random method, but it is not a concrete or an evident method. What specific functions should the system attempt to learn? What are the features it should take? Right? Till now, it is again a question mark. How can the learner automatically alter its representation? I have a signal, but I am not interested to work in a signal. I want to convert a signal to image. In that case, will there be any loss? But with that image also, can my system automatically identify and take a decision? Remember, as I told you in the first class, it is all about decision making, right? Becoming like a god, predicting future. What happens next? What happens next? Machine learning is all about telling what happens next with the past data. But how can it do? Only God knows.
Yes, sir.
Excuse me, sir, you're on mute.
Hello, is my voice audible?
Yes,
Yes,
sir.
sir.
Okay. I think you missed my voice earlier a bit.
Yes, sir.
Okay. Tell me the attendance. Amulya, Can you hear me?
Yes, sir.
Yes, sir.
Okay. Now tell me the attendance. Amulya. Amulya absent. Okay. Judson.
Present, sir. Present, sir.
Judson. Judson absent. Samyukta.
Present, sir.
Angel.
Present, sir.
Pavan. Pavan.
Sir, Ajit, present, sir. Present, sir.
Ajit. Okay. Abhinaya.
Yes, sir.
Kiran Kumar.
Yes, sir.
Manideep.
Present, sir.
Bhanuteja.
Present, sir.
Jennifer.
Yes, sir. Yes, sir.
Priyadarshini.
Yes, sir.
Afreed.
Present, sir.
Jayant.
Yes, sir.
Vikas.
Present, sir.
Paul Finney.
Present, sir.
Bhuvaneshwar. Bhuvaneshwar. Bhuvaneshwar absent. Sumant.
Present, sir.
Ramesh Kumar.
Present, sir.
Neeraj Kumar.
Yes, sir.
Zubair.
Yes, sir. Present, sir.
Kirti. Kirti. Okay. Dinesh.
Present, sir.
Tejaswant.
Yes, sir.
Priya.
Present, sir.
Karthik.
Yes, sir.
Jenish.
Present, sir.
Rex.
Present, sir.
Harshavardhan.
Present, sir.
Uday.
Yes, sir.
Mohammed. Mohammed Saqib. Not there. Okay. Mohammed Saqib absent. Siddharth.
Yes, sir.
Praneeth.
Yes, sir.
Salome.
Yes, sir.
Livingston.
Yes, sir.
Alan.
Yes, sir.
Ronan. Ronan absent. Ronan, okay. Sai Kiran.
Yes, sir.
Joshiba.
Yes, sir.
Shiny.
Yes, sir.
Jasmine.
Yes, sir.
Celestine.
Yes, sir.
Jayasuriya.
Yes, sir.
Manasa.
Yes, sir.
Ashrita. Ashrita. Okay. Narasimha Reddy. Okay. Puneet Kumar.
Yes, sir.
Shiny.
Yes, sir.
Joshua.
Yes, sir.
Nagakiran.
Yes, sir.
Suraj. Suraj. Maunika.
Yes, sir.
Taufik.
Yes, sir.
Manideep. Sai Manideep. Sai Manideep absent. Okay. Dikshit.
Yes, sir.
Marie Angel. Okay. Amrut.
Yes, sir.
Pavan Kalyan.
Yes, sir.
Sainath.
Yes, sir.
Gautam.
Yes, sir.
Jagat Chandra.
Present, sir.
Vivekananda.
Yes, sir.
Shashank.
Yes, sir.
Sai Ganesh. Sai Ganesh. Sai Ganesh absent. Gopi Chand.
Yes, sir.
Ritvik.
Yes, sir.
Solomon. Solomon Raj.
Yes, sir. Present, sir.
Sudarshan.
Yes, sir. Present, sir.
Sujit Kumar.
Yes, sir.
Suresh Kumar. Suresh Kumar. Sunny.
Present, sir.
So the absentees URK 18 EC 128 Sai Ganesh, Sai Manideep 18 EC 104, Zero 46 Mohammed Saqib, and 024 Bhuvaneshwar. 024 Bhuvaneshwar and 007 Judson. Okay. Students, if you have any doubts, we have completed the introduction section. If you have doubts, you can ask me now. Please, whenever you come to, at least for machine learning class, because it is not that concepts, the topics which you are going to listen in the class is not something usual to you, right? It is different. So I request you to refer my PPTs which I have uploaded, and then come to the class and you can clarify doubts, or if you have any discussions, we can also have discussions, right? If you have any doubts, we can make use of the next 5 minutes now, or if you don't have doubts, you can leave the Google Meet.